Okay, well, we've got our main PowerUp logic in place. So now the next thing to do, I think, is incorporate some logic to decide what the conditions are for engaging the PowerUp meter, decrement from it and so on. And then actually decide what the PowerUp gives us, what kind of game mechanic it introduces. So let's start in the PowerUp manager by creating a field to store our PowerUp state. So either on or off. On, off. What type do you think would best store this information? That's right, a bool. So let's do that right now. Let's say public bool is powered. We're going to need it to be public, I think, so other classes can access it. And we'll start off, when the script starts, we'll just set that to, well, it already defaults by default to false in C#. Bools default to false. But let's set it explicitly in the start so we know what it's supposed to start off as. And then here, what we can do is we can make a little conditional block. So we'll engage the PowerUp under these conditions. So if input.getKeyDown, which I'll talk about a bit in a second, how that's different from simply getKey. Key code, well, I want to use map it to the Z key on the keyboard. So if that key is pressed and we're not currently in a powered up state, and of course if we have any PowerUp meter to spend, if we don't, then it won't work. So we'll want to make sure that we have more than 0 in our PowerUp meter. So under that condition, we don't know what it'll mean to be powered up just yet. So let's just start off with, let's make a comment, say start PowerUp mode. All right, and else if, so we're going to want to cancel the PowerUp mode if we're already in it and we press the same key. So Getkeydown, do the same thing, key code Z. And of course we have to be powered up in a powered up state for it to cancel. And again, we'll determine the logic of what canceling the PowerUp actually means. We're setting it, I guess, to the pre-powered up state. We'll figure that out later. All right. Okay, so you notice we use the Getkeydown method instead of just getKey. So this method returns true once, as soon as the key is pressed, and then returns false even if you hold down the key. So it only returns true when and if you strike the key, and then if you strike it again, right? So this is very useful for trigger type behavior. If it were otherwise, if we used simply input.getKey and we held down the key, it would require you to hold down that button just to keep executing this conditional code block. So we could do that, but I think being in a powered up mode should be more established as a trigger type process rather than actually holding down a button and then letting go to not execute that code block. So that's why we used input.getKeyDown. So what we should do now is create some behavior for the first if clause where it evaluates as true. So we know we want to set the isPowered bool to true to start PowerUp mode, and we'll want to count down the meter, right? Decrement, in other words. But we'll want to put the countdown meter in another if statement that counts down only so long as isPowered is true. So let's do this. Simply say isPowered is true. And of course canceling would be tantamount to saying isPowered is false. And now here we will determine what it means to be in a powered up state. So if isPowered is true, so just write down the variable name and it will read as isPowered is equivalent to true. Well, we'll want to decrement from the meter, so say PowerUp meter minus minus, and have another conditional that's checks if the PowerUp meter is equivalent to 0. And basically what that should mean is PowerUp state should exit. It should be false. So that's pretty simple. Is powered equals false. Pretty logical stuff, huh? This is not complex. And, well, this is less than ideal, but we'll output it to the debug log, the PowerUp meter, so we can check that the decrement is working fine, just like that. And just to make it clear, the reason why we checked the PowerUp state in a different conditional, you may have thought, why not just do it in the part that checks whether or not we satisfy those conditions to make is powered true? Well, because remember, this first Getkeydown part of the evaluation, it checks to see if the key is just struck down. So in other words, this block really only executes on that frame, right? If you keep holding down the key, or if all these other evaluations evaluate as true, it won't continue to execute this code block. It will just execute on that one frame. But we're going to want to execute this on successive frames so long as we're in the PowerUp state. All right, so that's why we did it in its own conditional statement. All right, so let's run this now and look at the console to see what's happening with the meter. We give the PowerUp meter a 50 integer startup bonus, so we'll see how it decrements when we hit the Z key. Sure enough, there we go. And, well, I didn't really catch it, but I think the public bool here, it canceled automatically when it reached 0. So let's just try that again. Yep, there we go. And we'll also want to try canceling it ourselves before it cancels. Yep, works well. Okay, so this is working, but there's a problem, as you can see, with this temporary output to the debug log of the PowerUp meter. But we have to do this right now because, well, for whatever reason, the inspector, it won't show us the public static field for the PowerUp meter. It'll show other public fields, but if it's static, it just doesn't show in the inspector. So this is less than optimal because, as you can see, it will decrement on every frame and spit out the result to the debug log and overwhelm pretty quickly. But, this is just all temporary till we can find a way to display the meter, which I think we'll do in the next video. So before we go to fixing that, now let's go on to considering what kind of PowerUp we can actually implement here. So how about we slow down the game, which in this case, we would just want to slow down the speed of our cube player as well as the sphere enemies. And we can do this actually very easily by just referencing the speed fields that we use, remember, as a multiplier of sorts to determine how fast our characters travel, right? So simply reduce those fields when in PowerUp mode, else when not in PowerUp mode, put it back to its normal speed, right? So let's go to the cube controller script. And while we're at it, why don't we slow down the speed of our characters in general, because we know the game is going to get pretty overwhelming pretty quick, right, as we're duplicating enemies at a pretty fast clip. And we want to have a fighting chance when things get hectic. So let's just change the speed, the default speed, to 7 for our cube. And for the sphere, let's make it a little bit slower again, 6.06, I should say. And since in the PowerUp Manager, we're going to want to reference these fields, we're going to want to make them both public static. Static because we're not going to be really able to access the instance, at least not easily. It's just more easier to make it static as we've been doing so far. So let's make them both public static. Right? And now we're going to want to reference them in our little logic blocks here in the PowerUp Manager. So we'll want to do it here when the trigger is activated, so we don't keep decrementing the speed. We only, on that frame, as soon as we engage PowerUp, start decrementing. So let's say cube controller dot speed equals, now let's just go to half speed. Let's make it cut the speed in half in PowerUp mode. So let's say cube controller dot speed multiplied by 0.5, right? That should do that. And we'll also want to access the sphere controller in the same way. So actually I'll just copy this and we'll make both the player 1 and the enemies cut their speed in half. Right? And well, when we cancel out of this, we're going to want to double it, right? To go back to its original value. So let's multiply it by 2 to double it. Pretty easy. And here we'll also want to repeat this when it automatically cancels, right? Okay, so let's run this now and see how it works. Now I can't go into PowerUp state without a PowerUp. Leave PowerUp state, go into PowerUp state. Let it automatically leave the PowerUp state. Yep, seems to be working fine. Alright, that seems to be working. Okay, so our logic works, but it's kind of ugly. In particular, the simulated time change mechanic is being repeated in both conditional evaluations. So what do you think we should do when we see repetition? That's right, we should consider refactoring it into its own method. So let's do this really quickly. Let's make a method beside update, call it private void time change. It takes in a float, call it speed factor, local to this method that will pass in where we call this, and we'll basically take this part right here and will allow us to multiply by our speed factor, which will be different depending on if we're entering or exiting the PowerUp mode, right? And, well, we can also just, we can remove this from there too. We can put it right in here because we know we're going to want to either enter or exit out of is powered state. So we can just really simply do it this way. Say is powered equals the opposite of is powered. So it'll have a little switching behavior, you know, built into the bool. That's why bools are so useful for this state keeping type of mechanic. And then here, take this fairly large code block, and actually we can just put, I will lose the comment unless I put it after the time change call here, but as you can see now I can put it all on one line of this method call. So we'll change the time to 0.5, or we'll multiply it by that amount to get half. And here we'll just multiply it by 2 so we can get back to original value, right? And same thing here. All right, a little bit cleaner, a little bit easier to read. And I'll just put a comment. Yeah, I'm calling it change time. I know that's kind of a misnomer because actually what we're doing is changing the speed of the characters, but nonetheless it has the effect of changing time. That's how we'll probably be thinking about it. Let's just quickly try that out to see if it's still working correctly. So not powered up, right? Again, another power up. and let it run out. Great. All right, well, I think we should probably leave things like this for now. I know we can keep refactoring and going on and on with that, but I want to just sort of keep things moving, and we can always come back when we're closer to finalizing the project. So, all right, well done. We'll end the video here and tackle the next problem in the next video. Thanks.